Life of a star. Though stars are not actually living, they do appear to go through a process rather like being born, living, and dying. When stars last for billions of years, how do scientists manage to work out their life cycle? Well, if you imagine an alien spending a few hours in a forest, they would see trees of different sizes, including saplings. They would see seeds, and possibly a sprouting seed. They would also see dead trees. From these snapshots of tree life, they would be able to work out the life cycle of trees, even though trees can last over 100 years. In a similar way, astronomers can observe stars at different parts of their life, and from these snapshots work out the life cycle of stars. Stars begin as a cloud of dust and gas, mainly hydrogen nuclei or protons. Gravity will cause the cloud to collapse, and the loss of gravitational potential energy will lead to a rise in temperature. So inside the cloud now we have protons which will be moving around incredibly rapidly. Some of these may eventually fuse to form helium. It's a rather more complicated process than this, involving several stages. But this is called nuclear fusion. This releases huge amounts of energy, and from this process a star is now born. The process of nuclear fusion is joining smaller atoms to form larger atoms, and this will continue while the star is on the main sequence. Larger stars have more hydrogen to fuse, but use it much faster and so have shorter lifespans. What happens now depends on the size of the star. We'll look at a star the size of our Sun. As the hydrogen runs out, the star will start to collapse, which will raise the core temperature. Helium fusion now starts in the core, and hydrogen fusion will start in the outer layers. The star will expand and cool to become a red giant. Helium fusion will continue in the core, raising the temperature further, but when hydrogen fusion in the outer layers is over, the star will again collapse and get hotter still, to form a white dwarf. What will this mean for our Sun in terms of the Hertzsprung-Russell diagram? Well, at the moment the Sun is here. As its temperature drops, it will move towards the right as the temperature scale decreases to the right on a Hertzsprung-Russell diagram, but it will also get larger, becoming more luminous, and become a red giant. Its temperature will then rise, moving across here, but eventually it will collapse, losing luminosity, to become a white dwarf. Let's see that. Eventually, the Sun will simply cool and fade away. But larger stars can have more complex endings, forming neutron stars, supernova explosions, or even black holes.